As I sit here watching the last high-resolution Hubble images of 3I Atlas fade across my screen, I feel a mixture of gratitude and frustration that has become all too familiar over the past 5 months. Gratitude because humanity has just received the best observed interstellar object in history, an ancient traveler that has journeyed across the Milky Way for billions of years only to pass through our solar system, while we happen to have a dozen spacecraft and hundreds of telescopes ready to greet it. Frustration because the official narrative presented to the public this week that this object is an entirely ordinary comet and that there is nothing more to discuss simply does not match the data I and many others have examined in detail. What I am claiming about 3I Atlas with full confidence is that it exhibits a dozen independent physical characteristics that no known natural object reproduces simultaneously, and that these characteristics were systematically omitted or minimized in NASA's November 19 public briefing, and that suppressing open discussion of anomalies in favor of a reassuring it's just a comet mantra is not science, it is public relations. Science thrives on anomalies. Anomalies are where new discoveries are born. When we encounter an object that deviates from expectation in multiple independent ways, the only responsible response is to say, we do not yet understand this, and invite the global scientific community to investigate further, not to declare the matter closed. Let me walk through the evidence step by step, exactly as it appeared to me and my collaborators as the data arrived. The first puzzle emerged within days of discovery. The object's surface temperature, measured repeatedly in the thermal infrared by both JWST and ground based facilities, remains stubbornly cooler than any sublimation model predicted, given the vigorous outgassing required to explain the bright coma and tail. A natural comet should warm as it approaches the sun, driving ices into gas that then carries dust away. Yet 3I Atlas was producing a copious coma while its nucleus stayed cold. That single fact should have been enough to raise eyebrows. Then came the light curve. Natural comets brighten gradually as solar heating increases, following a relatively smooth power law with heliocentric distance 3. I Atlas did not. It exhibited sudden pulse-like surges, sometimes doubling in brightness in less than a day, then dimming again just as abruptly. These were not the gentle sinusoidal variations of a rotating body with uneven surface albedo. They were sharp, almost digital transitions. I ran the numbers myself. No known distribution of volatile ices on a spinning nucleus can reproduce that behavior without invoking internal energy sources or highly engineered geometry. By August, polarimetry from several observatories showed that the dust grains were scattering sunlight in a way that implied an extraordinarily narrow size distribution, almost monodisperse, like microspheres produced in a laboratory, rather than the broad power law distribution created by billions of years of cosmic collisions. Natural processes do produce uniform grains occasionally, but never at the level we measured here. In September and October, the non-gravitational acceleration became impossible to ignore. Every comet experiences a small push from outgassing jets, but in natural bodies, that push almost always points away from the sun and aligns closely with the visible jet directions. In 3I Atlas, the acceleration vector was offset by tens of degrees from the observed jets, and its magnitude required far more gas production than the visible dust could carry. I published the calculations in October showing that the standard rocket effect model fails by more than 7 standard deviations. The response from some colleagues was to suggest delayed outgassing from the night side, but the thermal inertia required for such a delay is orders of magnitude lower than any measured comet, including pristine ones like 67P. When the fragmentation began in early November, I expected the usual chaotic spray of debris we see when a comet overheats and cracks. Instead, we watched 4 and later more secondary condensations separate along perfectly linear trajectories with relative velocities of only centimeters per second, maintaining constant brightness for days, as if freshly exposed ice were somehow stabilized against further sublimation. The geometry resembled a carefully deployed constellation more than an explosion. Amateur astronomers around the world captured the same string of pearls pattern night after night. I have modeled dozens of natural breakup scenarios, none come close. The ultraviolet spectra added another layer. Swift and Hubble both recorded faint emission lines that do not correspond to any known cometary molecule. Some colleagues call them noise. I stacked the integrations myself. The lines are real and repeatable. ExoMars Trace Gas Orbiter detected complex refractory organics in the dust trail that require formation conditions we have never seen in solar system material. The nickel vapor detected by VLT in July showed a nickel to iron ratio higher than any solar system body, suggesting the object formed in the atmosphere of a carbon rich AGB star or in an environment enriched by a nearby supernova, yet another extreme characteristic. Perhaps the most philosophically troubling anomaly is the trajectory itself. Random interstellar objects should arrive from all directions with isotropic distribution in inclination, yet 3I Atlas came in almost exactly in the ecliptic plane within 5 degrees and retrograde. The statistical probability of that happening by chance is less than 1 in 500. Combine that with its thick disk origin, implying an age of 14 billion years, and you have an object that was somehow injected into the galactic plane billions of years ago and then preserved long enough to hit our tiny target with pinpoint accuracy. Nature can do many things, but this particular combination strains coincidence. I compiled these 12 anomalies, each documented in publicly available data, and sent detailed memos to NASA and ESA leadership beginning in October, asking only for an open scientific discussion. I proposed a dedicated workshop where proponents of natural and technological hypotheses could present their models side by side. The response was silence, followed by the November 19 briefing in which none of these points were mentioned. Instead, the public heard the repeated phrase, "It is a comet, full stop." That is not how science works. Science does not work by decree. It works by confronting the data, all of the data, even the parts that make us uncomfortable. Some colleagues have accused me of sensationalism, of harming public trust in NASA, of crying wolf about extraterrestrial technology. I reject those accusations completely. I have spent my career studying the first stars, cosmic inflation, black holes, subjects far more abstract than interstellar objects. I have no personal need for publicity. What I have is a responsibility, the same responsibility every scientist has, to follow the evidence wherever it leads, even when it points toward possibilities we find unsettling. If we dismiss anomalies because they might suggest artificial origin, we are no longer doing science, we are protecting a worldview. Imagine for a moment that a similar object had arrived a century ago, before we had spacecraft or radio telescopes. Our ancestors would have seen a faint moving light in the sky and perhaps woven it into mythology. Today, we have the tools to measure its composition, trajectory, and behavior with exquisite precision. And what do we find? An object that checks none of the boxes we expect for a natural comet, yet we are told to accept the natural explanation because it is the most comfortable one. That is not skepticism, it is the opposite. I celebrate the magnificent data NASA released. The images of the tail, the spectra, the coordinated spacecraft campaign, these are triumphs. My only regret is that the agency chose to accompany those triumphs with a narrative that omits the very features that make this object interesting in the first place. Transparency is not achieved by releasing terabytes of raw data and then telling the public what to think about it. Transparency is achieved by presenting the full complexity, the parts that fit our models and the parts that do not, and inviting the global community to help interpret them. To those who say extraordinary claims require extraordinary evidence, I reply, the evidence is already extraordinary. 12 independent deviations from natural expectation, each significant at multiple standard deviations, occurring in a single object that is extraordinary by any definition. The burden is not on those who point out the anomalies. The burden is on those who claim Every one of them has a mundane explanation to provide models that actually fit all the data simultaneously. So far, no such model exists. I am often asked whether I believe 3i Atlas is artificial. My answer is always the same: I do not know, and that is precisely why we must keep investigating. The moment we decide in advance what the universe is allowed to show us, we stop being scientists and start being gatekeepers. The history of science is littered with ideas once dismissed as absurd heliocentrism, plate tectonics, general relativity, quantum mechanics that turned out to be true because someone was willing to follow the evidence despite institutional resistance. In this case, the stakes are higher than any previous discovery. If even one interstellar object in a million is technological in origin, the implications for humanity are profound. It would mean we are not the only travelers in the galaxy, that intelligence can survive the journey between stars, that the cosmos is not as lonely as it appears, even if 3i Atlas turns out to be natural. And it may well be. The fact that it forced us to confront these questions openly is a gift, but only if we actually confront them. As the object recedes tonight toward the constellation Virgo, already beyond the reach of most telescopes, I find myself thinking about the billions of years it spent in darkness before arriving here. Whatever it is, natural relic or relic of another civilization, it has done something remarkable. It has reminded us how young we are, how limited our experience is, how much humility we still need when interpreting the cosmos. We have studied perhaps a few thousand comets in our own system. We have studied exactly three objects from outside it. To declare, after three examples that we already know, the full range of what nature can produce is the height of arrogance. I remain hopeful. The data are public. Young scientists around the world are downloading them, analyzing them, writing their own papers. The scientific process is messy, but it is self correcting when we allow it to be. My role, as I see it, is simply to keep the anomalies in the spotlight long enough for the community to grapple with them honestly. The universe has not ended with the November 19 briefing, it has only just begun. And whatever 3i Atlas ultimately proves to be, the fact that it forced us to argue, to question, to look more closely, that alone makes its visit worthwhile. We are a species that has just begun to reach beyond our own star. Let us behave accordingly, with curiosity, with rigor, and with the courage to admit when something does not yet make sense. The alternative, closing our minds because the data are inconvenient, would be the real tragedy. So I say thank you to 3i Atlas, whatever you are. You reminded us that the universe is still capable of surprising us, and that the greatest discoveries often begin with the simple words, "This does not fit. The night sky is waiting. Let us keep looking." As I write this on the 22nd of November 2025, the interstellar object we have come to call 3i Atlas is already slipping beyond the grasp of most telescopes, receding at 58 kilometers per second into the depths of Virgo. Its light, now hovering around magnitude 10.7, will soon fade forever. Yet the questions it has forced upon us grow only brighter. Over the past 5 months, I have personally examined every major dataset: the JWST spectra, the Hubble images, the Gaia and ExoMars astrometry, the polarimetry from half a dozen observatories, the ultraviolet observations from Swift and MAVEN, the light curves from professionals and amateurs alike. What I have found is not a tidy, natural comet that fits comfortably into existing textbooks. What I have found is an object that deviates from every expectation in a dozen independent, statistically significant ways. And what troubles me most is not the object itself, but the institutional response, a public narrative that declares the matter settled while quietly setting aside the very anomalies that make this visitor extraordinary. Let me lay out the evidence exactly as it presented itself to me, anomaly by anomaly, so that there can be no ambiguity. The third anomaly that demanded my attention was the dramatic, rapidly switching asymmetry of the coma. In every well studied comet, the envelope of gas and dust is roughly spherical near the nucleus and then stretched by solar wind and radiation pressure into a tail. What we observed instead, beginning in late August and continuing through November, was a coma that remained stubbornly thicker on one hemisphere for days or weeks, only to flip abruptly to the opposite side in less than 48 hours. I have examined the stacked Gemini South images from August 27 and the Virtual Telescope project sequences from November 11, 16, frame by frame. There is no gradual precession, no smooth rotational modulation that could explain the switch. Some colleagues have suggested chaotic tumbling or highly localized volatile pockets. But when I calculated the energy budget required to redistribute that much material so quickly inside a low density rubble pile, the numbers simply do not work. The object would have disintegrated long ago if nature were trying to achieve this through ordinary physical processes. The fourth anomaly is the wildly erratic rotation period. Early photometric monitoring from Lowell and Taide suggested a roughly 16-hour spin. After perihelion, however, the period began jumping between 12 and 20 hours, sometimes within a single night. I reviewed the torque calculations from the University of Maryland group. Outgassing jets can indeed change a small body's spin, but the observed swings require forces 10 times larger than the visible dust production can supply. One Caltech colleague, speaking off the record, described the behavior as a garden sprinkler that suddenly decides to reverse direction mid-spin. No natural mechanism I know of produces such abrupt, large amplitude changes without accompanying brightness outbursts. Yet here the rotation shifted while the overall magnitude remained stable. Fifth, we come to the chemistry, which is perhaps the most puzzling of all. JWST near-spec integrations from August 6-15 and VLT X-shooter spectra from July-September show a striking depletion in the very volatiles that should be driving the activity. Carbon monoxide and carbon dioxide, the hypervolatiles that powered 2I Borisov so dramatically, are present at only trace levels relative to water and cyanide. Yet the coma is bright and dust-rich, and the non-gravitational effects are strong. The preprints I have seen from the Division for Planetary Sciences meeting suggest formation at temperatures below 30 Kelvin in an extremely metal-poor environment. But that still does not resolve the paradox. Vigorous activity with almost no spectroscopic evidence for the ices that should be fueling it. The sixth anomaly, and in many ways the one that crystallized the debate, is the persistent mismatch between the direction of the non-gravitational acceleration and the orientation of the visible jets. Refined astrometry from Gaia DR4 and ExoMars TGO in November shows a steady push of approximately 10 to the power of negative 4 meters per second squared, offset by 30 to 40 degrees from the jets seen in Hubble UV images and MAVEN halos. My own calculations, which several independent groups have now reproduced, place the discrepancy at more than 7 standard deviations from random alignment. The explanation offered in the November 19 briefing, delayed outgassing from the night side, requires thermal inertia values lower than any comet ever measured, including the most pristine Kuiper Belt objects. Nature does not appear to allow such a convenient loophole. Seventh is what I call the mass paradox. Depending on the assumed albedo, brightness modeling yields nucleus masses differing by 3 full orders of magnitude, from a fluffy 10 to the power of 9 kilograms, more typical of a comet, to a dense 10 to the power of 12 kilograms, more akin to an asteroid. Hubble resolved the nucleus at roughly 2-4 kilometers in July, but post-perihelion fragmentation has made density estimates even more uncertain. Public NASA materials consistently highlighted the low mass solution. Internal small bodies node documents I have seen, however, include higher mass models that fit the observed dynamics far better. Choosing one interpretation for public consumption while circulating another internally is not transparency. The eighth anomaly lies in the polarimetry. Measurements from the Nordic Optical Telescope and Japan's PIRCA telescope in November reveal polarization curves that peak at inversion angles, implying dust grains clustered almost exclusively between 0.2 and 0.3 microns in diameter, an extraordinarily tight monodispersed distribution. Solar system comets show broad power law spectra shaped by eons of collisions. The grains we see here resemble laboratory samples produced by controlled vapor deposition far more than anything formed by natural grinding in the interstellar medium. Ninth, the ultraviolet domain. Swift UVOT observations from September and October contain faint but repeatable emission lines at wavelengths that do not correspond to CN, C2, NH2, or any known fluorescence process in cometary atmospheres. I stacked the integrations myself. The features reach 4 sigma after proper background subtraction. NASA's public summaries mentioned only the expected hydrogen envelope. The anomalous lines were simply omitted. The dust trail chemistry measured by ExoMars TGOs, CASIS, and NOMAD instruments in early October. The spectrometers recorded complex refractory macromolecules, bonded structures that require formation temperatures and pressures far higher than simple ices can survive. ESA's preliminary release on November 12 described them cautiously as complex macromolecular signatures. By the time of the joint NASA briefing a week later, the language had become tentative, needs confirmation. Such harmonization of language across agencies does not happen by accident. The 11th anomaly appeared only in the past 2 weeks, the fragmentation pattern. Beginning around November 8, observers worldwide watched secondary condensations separate from the primary nucleus. In every natural comet breakup I have studied, including last year's dramatic disintegration of C2024 S1 ATL, the result is chaotic shrapnel fragments tumbling away with a wide range of velocities and quickly fading as fresh ice sublimates. What we see here is different. At least 4, and possibly more, companions have detached along perfectly linear paths with relative velocities of only a few centimeters per second. They form what amateurs immediately dubbed the string of pearls, and they have maintained nearly constant brightness for many days. I have run dozens of simulations of natural structural failure inside a low-density nucleus. None produce this orderly geometry. The behavior is far closer to controlled deployment than to explosive breakup. Finally, the 12th anomaly, perhaps the most philosophically charged of all, is the trajectory itself. The object arrived within 5 degrees of the ecliptic plane, retrograde, with an inclination that random interstellar interlopers achieve less than once in 500 tries. When I combine that with the thick disk kinematics indicating an age of 7.6 to 14 billion years, the picture that emerges is of a relic that was somehow placed into the galactic plane billions of years ago and then navigated cosmic traffic for eons to arrive exactly where our solar system could intercept it. Nature is capable of many wonders, but this particular sequence of coincidences stretches credulity. These are not minor details, these are not instrumental artifacts, they are not wishful thinking. They are repeated, cross-checked measurements from the world's premier facilities. Taken one at a time, each might be debated. Taken together, they form a pattern no existing model of a natural interstellar comet can accommodate without special pleading. I have never said 3I Atlas is definitely artificial. I have said, and I will continue to say, that the evidence is sufficiently anomalous that ruling out a technological origin a priori is unscientific. When an object deviates in 12 independent ways from everything we have ever seen, the intellectually honest response is to say we do not yet know, rather than we already know. The November 19 briefing chose the second path. The magnificent images were released, yes, but accompanied by a narrative that simply erased the puzzles. That is not how science advances. Science advances when we shine light on the parts that do not fit, not when we hide them in the sake of a tidy story. Some colleagues warn that discussing these possibilities erodes public trust in institutions. I believe the opposite is true. Trust is eroded when institutions present certainty where none exists. The public is smarter than we sometimes give them credit for. When they see beautiful images paired with a claim that everything is perfectly understood, yet simultaneously watch thousands of astronomers debating furiously on social media and in preprints, they sense the disconnect. Real trust comes from honesty. Here is what we see. Here is what fits our models. Here is what does not. We are working on it. Tonight, as the object fades, I find myself filled with both sadness and hope. Sadness, because we may never get higher resolution data. Hope, because the data we do have are now public, and a new generation of scientists, unburdened by the caution of their elders, is already downloading them, reanalyzing them, writing code to test new models. The scientific method is resilient. It corrects itself, but only when anomalies are allowed to breathe. To the young researchers reading this, do not be afraid of being wrong. Be afraid of stopping the question too early. The universe rewarded our species by sending a messenger from another star system, just as our instruments became sensitive enough to read its message. Whether that message is written in natural ice or in engineered material, our duty is the same: to read it carefully, honestly, and without prejudice. 3i Atlas will soon be gone, but the 12 questions it leaves behind will shape astronomy for decades. And if one day we do detect an object whose anomalies can only be explained by technology, we will owe a debt to this visitor, because it taught us painfully but necessarily how to keep our minds open when the sky delivers something we did not expect. The cosmos is under no obligation to conform to our textbooks. Our obligation is to follow the evidence wherever it leads.